Hello everyone, welcome to this session. And my name is Prakash Balaguru. I'm taking care of product business in Rockwell Automation, taking care of server business. And today's discussion, we are going to talk about what is all about the smart conveying system. I am without further delay, I'm welcoming Jayendran Balasubramanian from NextFirst. He is one of the pioneer in ICT technology and making a couple of missions to our customer. Welcome, Mr. JB.
Hi, Prakash. Thanks a lot for Rockwell for inviting me to participate in this session. Thanks, Prakash, for the warm introduction. I don't want to spend too much time talking to you guys. I think Prakash has a phenomenal set of videos that we're going to show you guys today, showing how ICT is being helped to ICT is helping build smart conveying technologies of the future. I wanted to spend a few minutes kind of trying to understand why is smart conveying important at all, right? I think around us, manufacturing and supply chain is going through these industries are going through a sea change. I'm going to try to not use the word pandemic when I talk, because even without the pandemic, this change has been happening. I think these changes are motivated by three big macro trends. The manufacturing industry has been chasing the holy grail of mass customization or hyper personalization. Driving production planning and manufacturing system design in such a way that every subsequent product that has been manufactured can be a different product. I think this is a change that we're all seeing happen around us for the past few years. Businesses, companies are also rapidly transforming themselves to become omni-channel in the way they produce and they distribute goods. What this means is the same particular product, if in a packaging line, one SKU will be one-off going to an e-commerce channel. If it is going through a discount store channel, will be very large quantity. If it is going through a retail, will be a different pack size. So omni-channel distribution strategy has been kind of driving again a lot of flexible packaging requirements. And at a broader level, supply chains are moving from being supplier or manufacturer centric to demand or consumer centric. So the entire supply chain, which traditionally was designed to go to a manufacturing location, take goods away, and then somehow get it to a consumer, is now reorging itself to put the consumer in the center. So these trends are forcing the entire manufacturing and supply chain industries to become agile, flexible, configurable in the real time. I mean, these are words that all of us as automation professionals are being asked by our customers to implement in our automation strategies. What's happened in the past few years is production automation systems, leveraging technologies like robotic process automation, machine vision and computer machine vision, have all kind of enabled production systems to become flexible and agile. And I think the material handling systems have been kind of lagging behind. Material handling systems are still on traditional kind of sequential conveyor-based material handling. And I think smart or flexible material handling to support a flexible manufacturing is becoming more important than ever. In this context, as an automation professional, I'm super excited by the suite of products that we're here to talk to you today about, which is called the independent cart technology that Rockwell has. At NextFirst, we built a platform called Cart Plus. That's a smart material kinetics platform. You can learn more about that by visiting our website. I'm handing the mic back to Prakash now, and Prakash is going to kind of have an exciting presentation to all of us, showcasing how Rockwell's ICT products are helping create smart conveying automations of tomorrow. Over to you, Prakash.
So that's really a good insight with respect to what's happening on the smart conveying system in manufacturing and supply chain industry. I think with that quote, I think I'll just take you through the presentation wherein we talk about what is all about the smart conveying system. Let me just present my screen. Give a minute. I'll just present my screen so that, I guess is visible to everyone. I guess so. So what is all about the smart conveying system? So what we call it is actually a ICT, which is the independent cart technology. So before we jump in on the independent cart technology, I'm just taking the quote from JB, that how it is going to help on the hyper customization, as well as on the different set of SKUs. How do we handle the different set of SKUs without taking much time on the changeover, and also from the supply chain point of view, moving from supply centric to the demand centric. So that we will see that, and I think before we go into the deep dive onto the benefits and features and values, I just wanted to put it across what do you mean by the ICT is all about. If you look at on the traditional conveying system, wherein you have the conveyor belts and then motors, rollers, and then chain conveyors, etc., right? So when you look at on the ICTs, it is actually based on the magnetic levitation technology, wherein actually you have linear motors. You can see that on the bottom, which is the fixed magnets, and then you have the moving cart, which is actually moving on top of it, right? So that is like it is, we call it as is actually the ICT, which is the independent cart technology. It's not just only on the reduction of moving part and then moving to the linear motor based one. If you look at on this particular video, you can able to see that all these moving parts, which is actually you can think of it as a pallets, or we call it as it is a cart. You can think of it as a pallets, which is on the conveyor. In the traditional conveying system, you can't able to control the each and every palletizers. If you look at here, you can able to control independently in each pallets, and you can able to the way you want, you can able to move the independently on the carts, and that can actually able to do the flexibility in terms of the operation point of view. It is very, very flexible, and it will increase your throughputs. So that's all about the quick introduction about the independent cart technology all about. And let us actually quickly go through the broad differentiation between the traditional conveying system vis-a-vis with respect to the ICT technologies. When you look at on broadly, which is the hardware is actually a most scalable one in case of ICT, because you can able to easily scale up and scale down so quickly without taking much time. And then about the throughput, if you look at 2.5 meter per second, that's the acceleration which we are talking about in terms of ICT. But vice versa with respect to the traditional conveying system, which is actually a 500 feet per minute, which is actually a slow, right? And the time to market perspective, we can able to simulate whenever we are going to expand it, and then you can able to simulate that, and then before we go into the live, so which is actually reduce the time to market. And the floor space, if you look at it, it is up to 30%. You can able to reduce the floor space, and then 40% up to 40% you can able to reduce the energy also. So there are a lot of energy consumptions, and since there is no rotation parts, and then it is going to be a completely a magnet based one. So obviously you can able to improve the efficiency and the reliability, and also there is no frictions and there is no contacts. There is no rotation parts, so that it is a very, very clean environment. Especially when we talk about the food and beverage and then pharma kind of industries, definitely yes, and this is actually a best technologies when we talk about the ICT. So this is all about the ICT when we look at it. I'll just go to few case studies examples that you can able to correlate what I'm talking about and what JB was talking about. If you look at the first case study, which is the KUKA is actually the OEM original equipment manufacturer for auto industries. They are manufacturing the transfer lines for the auto industries, especially for the assembly machines, assembly areas, body shops, wherever it's actually there is a transfer lines, they are manufacturing that. Look at actually this particular video. They talk about they implemented the ICT technology against the traditional conveying system. Their benefits are actually more. For an example, they reduced the MTBF. They increased actually the energy consumption was actually better, and there is no friction. The maintenance was drastically reduced. So let us actually look at the video, and you can able to come to know that.
From concept to reality, KUKA brings you the future today. By using linear synchronous motors in the rail and magnets on the chassis as its technology core, we've created the most efficient transfer system ever developed. With an initial investment substantially lower than that of other systems, the technical advantages stand out. It's 45% faster, allowing other equipment to be better utilized. There are 0 moving parts to generate thrust, thus eliminating hundreds of perishable items from factories. Downtime to repair has been greatly reduced, while mean time between failures has increased exponentially. With advantages of speed, reliability, maintainability, and flexibility, it also uses less power, which equates to even greater year-over-year savings. Second, third, and fourth models are seamlessly integrated with minimal downtime and lower costs than similar systems. KUKA Pulse, because the future starts today.
So that's about the KUKA. KUKA is actually implemented this one of the transfer line, wherein actually the chassis length is actually 4.2 meters and carries a weight up to 1.5 tons. And it can able to move to the speed of 22 feet with 3.2 seconds. So that's the speed and flexibility and increased MTBF and all about. And let's actually look at the different case study, which is for the tissue roll packing, wherein this is actually a European-based OEM where they are manufacturing the roll tissue rolls and then folded packaging machines and all that. And this machine is they developed very newly, and they call it as new revolutionary machine, because in the past actually they are manufacturing 3 different machines like BR221, BR421 and BR322 like that. So all these 3 machines have been brought down into the one machine. They integrated into one go, and they can able to swap this recipes, or I would say they can able to swap the SKU with no time, right? So with you can able to see that, and then you yourself can evident on this. So you can see that in the arm, which is actually get adjusted automatically based on the tissue rolls and packs, and based on the SKUs, based on the speed, it adjusted automatically. It is on the fly, which is actually happening, and that's how they can able to brought into 3 machines into one. So let's talk about the next case study, which is actually Comma. Comma is actually a North American OEM who is manufacturing the cotton boxes. And again, they are actually benefited out of this machine, this kind of technology based, which is the higher throughput, greater flexibilities in terms of different SKUs, and then they minimize the changeover in a drastic manner with respect to their traditional machine systems. I'll just play the videos again. It is self-explanatory.
This machine is called the IF318. It's a monoblock operating system, meaning that we have multiple functions within one framework. It is our formal introduction of this technology using 3 robots to do all functions: carton forming, packing, and sealing, all in a compact framework. This design's a conglomeration of multiple features. It's a demand from the customer for higher speed, greater flexibility, easier changeover, and sanitary design as well. The speed component is coming from, even though you have a monoblock system, you're able to have multiple different functions operating throughout the iTrack. So that is really a scalable machine that we can have multiple heads forming cartons, incorporate multiple boxes being loaded at the same time, and then multiple boxes being closed at the same time. Even though our motions are no faster, by forming, packing, and sealing multiple cartons in each station, it increases our speed. We have to be totally flexible in terms of the configurations that we put in this case. Machines like this that have fully robotic technologies allow for these different configurations to be simply changed over by our customer. Ease of use is really throughout the machine. We've incorporated many features in this machine, including RFID in terms of change part recognition, on the operator screen, step-by-step changeover procedures. The iTrack also helps in this because from a changeover standpoint, it has that pitchless technology that we can incorporate different patterns or pitches throughout the machine, changing that on the fly as the system goes, and also changing it from product to product. And our customers need a sanitary design. So what we've done is we've come up with a channel design where we run our cables all through these ribs throughout the machine. We put the panels on board so there's no more remote panels, but all surfaces are either set off or they're sloped to not allow any type of dust or condensation on the machine. The iTrack is a kinetics-based platform. That platform is seamlessly integrated with the ControlLogix PLC, the HMI, which is a panel view HMI, into one control package produced by obviously a single source, but also under the same operating and control platform. Both Kama and Rockwell have a global presence. So in terms of rolling out this system and all these features that we've talked about, we can do this on a global basis with our partner Rockwell.
Yeah, so this is like the third case study, which is the Kama one. I think I wanted to discuss with JB on a few things because he has actually, they have developed multiple machines for the e-commerce industries as well as for the CPG industries and all that. I wanted to talk about few things. Basically, when we talk about this kind of technology, the cost is actually, it is actually a matters. If you look at on the ROI periods, people will think that actually it is really a costly affairs, and then how we can able to get the benefits out of that. Of course, if you look at on the initial investment point of view, the capex is actually is slightly more when we compare with the traditional system. Right hand side is a traditional conveying system, whereas with respect to here on the left hand side, it is actually ICT technology. Of course, the capex is actually more, but slightly more, I would say. But of course, at the same time, if you look at on the installation, spares, maintenance, supports, downtimes, everything put together, if you look at it overall, the return on investment is actually better when we compare with the ICT technology. That's I wanted to ask, in fact, actually with the JB, because he's the one who is actually supplying multiple machines to our customers, so he can actually throw us some inputs on that. JB, are you there in the call? I think
I'm hopefully in the call. I was just engrossed watching the videos that you were playing.
Yep. So JB, I wanted to ask you, so with respect to the ROI of this kind of ICT technology, how do you explain to our audience, JB?
Prakash, good question on how companies look at ROI of automation technologies, right? See, I think in the we will have to evaluate. In my opinion, what I see customers doing is they're evaluating ROIs of any automation technology, various aspects of maintenance that happens over ownership that happens over a period of time. The cost of installation, the cost of software, the cost of upgrades, the cost of downtime, breakdowns, all of that put together, right? So if you just look at pure capex alone, which is a more traditional, older economy way of looking at any investment returns, I would say that not just ICT, any new technology will not compare well, all right? Because I think along with the ability to do a particular process, all new age technologies bring in the ability to be flexible, to be agile, etc., etc. Right? So all this put together, even at a total cost of ownership level, I would say that an ICT-based conveyance platform would earn itself back in roughly about 50 to 60% of the time that a traditional conveying system would earn itself back. So from an ROI perspective, the traditional conveying system may end up being about 60 to 80% more in terms of the time. But that's not where the magic is, right? I mean, if you look at manufacturing today, supply chain today, which is all demand centric, right, which is all around the consumer, versus traditional, which is all around the manufacturer or the source of production. In the traditional context, capacity chased demand. All right. So somebody set up a manufacturing facility, and then one go down or something came there, and then truck drivers came, and then logistics freight people came, and then they moved back. But in the new economy, fulfillment generates demand. So if you're able to actually fulfill orders faster, you're generating demand faster. I mean, all of us are users of multiple online, e-commerce platform, right? The one that is giving us the better experience is the one where we go again and again and again, right? So in that context, what ICT-based smart conveying systems do is they actually start giving you better turnaround times because they're very fast, right? You can start fulfilling orders much faster. You can start pushing more orders through the system. All of these metrics allow people to actually generate more demand and more output with lesser resources. If you were to factor that in, then the ROI on ICT technologies will be one order of magnitude faster than any conventional technology.
That's right. Yeah, that's right. That's a fair point, JB. I just stop my sharing, and then I do have one more question. If you look at it, like how the SKUs have been handled. I mean, you have done a very, very major e-commerce system. How you handled the SKUs and how it is really benefit in terms of SKU perspective, different SKU perspective, and the changeover time, of course.
Yeah. So actually, it's a very good question, Prakash. The entire concept of an SKU itself is becoming very important nowadays because any system is beginning to address one consumer's order, right? I mean, previously, if you had an automation system, which was, let's say, moving a pallet, right? You did not worry what are the various SKUs that were on the pallet, because you moved a pallet, the pallet was 500 kgs in weight. You could have had only one SKU, or you could have 100 different SKUs, right? Your automation system did not have to worry about the SKUs. But the moment you start looking at processing your entire automation around an agile, around a flexible, around a consumer-centric way of running your manufacturing, packaging, logistics, dispatch, etc., and you're doing all this around one consumer, right? Now, the unit of measure is only the SKU. And this ends up in typical processing centers being 100 to 1,000 times more than what it was in the traditional, material handling concept. The only way to handle this is in a real-time reconfigurable way. You cannot be going and making changeovers every time you want to change an SKU, because your changeovers, so to speak, will be happening at the holy grail of batch size of 1, where every subsequent order is a different SKU, right? So you cannot deal with, there is no concept of single minute changeover anymore, all right? It has to be zero changeover, or in the
on the fly.
Case, on the fly, or in the worst case, a software changeover. But fundamentally, it has to be no changeover.
I think well said. Thanks, JB, for your. I think it's actually really a good insight. I think let's actually hear it from the audience as well.
Yeah, and I think this is an exciting area, folks, and Rockwell and NextFirst have been having a lot of fun building some really cutting edge automation systems. So more than happy to answer any questions that any of you guys may have around the area of ICT and ICT based smart conveying.